time. So, welcome our first presenter.
All right. Hello, everyone. I'm Ali Palatel. Welcome to my talk, SETUID, an introduction to secure application sandboxing for Linux. Before I start giving you the fish, I'll teach you how to fish. So we have a CTF game. You can go with SSH or HTTPS, your web browser or whatever. Just go there, try to read the file etc CTF. SETBox is the only layer between you and that file. If you get to read it, there is a price. And we have a Git server, extensive documentation in the form of manual pages and mailing lists and so on. So I'll just wait a bit for everyone to take a photo. All right. Okay, so let's start a bit of history, a bit of who I am and what Exarbo is and how SETBox happened. I've been a free software developer for the good part of the last 20 years. I started with Gentoo Linux through the Gentoo Sunrise project. As some of you may know, Gentoo Linux is a source-based rolling release distribution, so every user gets to compile their own software on their own machine. In such a scenario, sandboxing is pretty much required to detect package build mishaps. Here you should be careful. We are saying package build mishaps, not malicious builds. It's really easy to get out of the Gentoo sandbox. So Gentoo sandbox, back in the day, is a LD preload based sandbox, and it has no network restrictions. LD preload, if you don't know, is a dynamic hooking mechanism, and it can be bypassed by static builds or directly running the syscall yourself. And then Exarbo Linux happened around 2008, and it was started by a group of ex-Gentoo developers with the idea to do Gentoo right. I will not go deep into Exarbo here, but there are two recommended watches on YouTube by Brian, who started the whole thing. So, and for our purposes, the importance of Exarbo is Exarbo, unlike Gentoo, has package testing on by default. So before you install each package, you get to run their tests on your machine as well. And then I joined Exarbo around 2008 to write a better sandbox, and SETBox 1 was the first stable release. Back then, it was written in C and was based on ptrace, and we had network sandboxing before even network namespaces were there, so it was pretty cool. We could restrict builds to loopback interface, and we had exec sandboxing to limit execution of binaries. And then SETBox 1 is stable now and has been and is still being used as the default sandbox of Exarbo. And over the time, I've started doing experiments, and Linux has also made new achievements in terms of sandboxing, such as seccomp, Landlock, and so on. And SETBox 2 was never really released. It was based on my experiments to actually make SETBox a security boundary. Security boundary, as in both SETBox 1 and Gentoo sandbox actually continue the system calls after the access check in the sandbox process, and as such they are very well known to be weak for time of check to time of use attacks, right? And then SETBox 3 happened around 2-3 years ago, I think, and it was a complete I wrote it from scratch in Rust because it was, for me, writing in C was getting really hard, and Rust was the obvious choice back then. So what is SETBox 3? And I will say SID when I say SETBox 3. We decided to name it SID so slotting the binaries is easier. It's an application kernel to sandbox applications on Linux. I say application kernel because SETBox does not continue the system calls in the sandbox process, rather runs the system calls on their own after the access check, and as such is not vulnerable to time of check to time of use. It's written completely in Rust. The only non-Rust dependency is libseccomp, which is widely available everywhere. You can install it with cargo. Make sure to pass locked, otherwise you may get dependency issues. It's licensed GPL3, it's forever free. It requires a relatively oldish Linux version 5.19, and with config seccomp filter, which is pretty much enabled on every Linux distribution these days. We have relatively good portability across architectures. We test around 7 architectures in our CI, and it's relatively minimal work to make SIDbox work on any new architecture, given libseccomp has support for it, because in SIDbox there is relatively little architecture-dependent code. So what is our philosophy? SID has the idea to make sandboxing as easy and as accessible as text searching is with grep. You may think grep is not that easy. SID is also not that easy, but once you get to learn it, you'll understand. So we follow the UNIX philosophy to do one thing and do it well. We do sandboxing, nothing else, because when you do system call interception, many fancy features are possible, but no, we try to keep it to a minimal. And our idea is to give you a simple interface for all the complex sandboxing mechanisms such as seccomp, landlock, user namespaces, and so on, which are all brittle and difficult to use, but we abstract them out with a simple API and give this to you. SID is secure by default with minimal overhead. Secure by default as in you don't need to read books to start using SID. All options in SID has the most secure alternative selected. And if you want to disallow things, then you need to know. And no extra privileges required. This is very important for us. We have no code in SID that uses SETUID, BPF, or Linux kernel modules, or any sort of extra privileges. You can just drop the binary as a regular user and just run it. And as a logical result of this, it can also be used as a login shell. For those who are in the CTF server already, you are running SID as a login shell right now. So let's start with our basic features. We do path sandboxing like AppArmor does, not like a Linux does. As such, we don't label or do inode-based tracking. We do path sandboxing, so we have read sandboxing and path masking. Path masking means any action is performed on dev null instead of the file itself. And we have write sandboxing and append-only paths. Again, this is a nice example. Linux does have append-only paths as a file system flag. You can change with ch-attr. However, this is privileged, unlike in SID, which is not privileged. Again, on the CTF server, the bash history file is append-only, so good luck covering your tracks. And we have stat sandboxing and path hiding, so you can actually change the visibility of file so it's completely invisible from the process. We have IRTL sandboxing to contain AI ML workloads. This is the fancy bit, right? But it's not as fancy as in gVisor. We do not actually keep track of all NVIDIA IOPTLs, but we have learning mode, so that gets easier. I'll show you in a bit. We have network sandboxing and we have support for UNIX IPv4, IPv6, Netlink, and kernel crypto API sockets. And a recent feature is we have application level firewalling with IP block lists. And our categories, sandboxing categories, are similar to those who know about Pledge. We have refined sandbox categories. I have listed them here. Like you can say allow read, allow write, or so on. Like you can use all these categories for sandboxing. On top of this, we have execution control, and this part depends on ptrace. You can completely disable this part if you want, but it comes with nice goodies that you may be interested in. As I said, it requires ptrace, and we have seccomp-BPF. For those who know GR security or who use hardened BSD will know, seccomp-BPF is an idea to block execution of binaries if they are crashing repeatedly. And this is a nice example where we have two different features of SID working together. We have a wider range of trigger signals than GR security, so you can actually add sandboxing rules to trigger seccomp-BPF. And as such, here is a simple rule I listed: kill, read, plus etc shadow. If you try with this rule, if you try reading etc shadow 5 times, and the binary you try to read will be delisted by seccomp-BPF. And then we have forced sandboxing, or verified execution to be more exact. Like you can verify binaries and library integrity at exec and mmap time. This is like very exec of NetBSD or hardened BSD's IntegriForce. However, we have a longer list of supported algorithms. And again, the default is the most secure one, you can guess. We have trusted path execution. Again, this is similar to GR security and hardened BSD. This with seccomp-BPF actually prevents a lot of attack vectors. As such, imagine someone confusing you to execute somewhere under TMP or such. This prevents that. And we have nice to haves. Like we have a lot of features. I cannot go through all of them here. I'll start going a bit faster. We have sandbox lock and dynamic configuration. You can do step-by-step configuration in SET as you do with pledge. You can run multiple pledge calls by taking away the privileges from the process, and you can do the same with SET. You can configure SET from within SET. This is the idea, and we set AT secure auxiliary vector by default, like AppArmor does. I think SE Linux you can do this too. The idea is to prevent LD library pet, LD preload, and all those from working. Another prime feature of SET is we enforce positional independent executables and therefore ASLR and also non-executable stack. And you can disable based on bitness, like you can disable 32 binaries or static link binaries or dynamic binaries or even scripts and so on. These are all you can also set dynamically. As I said, we have Debian-like fake root with the root fake option. This one is a small one, forcing UMask with trace force UMask. You can actually force a UMask to be passed to CH mode and all that. So given you have set trace force UMask 7177, the sandbox process is not actually going to make anything executable. Trace deny ... is for path traversals and so on. You mostly used in web servers, right, to attack them. And yes, this is our first slide, last slide, and as a bonus we have Landlock. You can use it with Landlock. We provide a nice API for it as well, and this way you can actually make a two-layered sandbox. Proxy sandboxing is another one where we put the sandbox process into a network namespace, bind the port to the loopback, send the port to the outside, and then some process does the forwarding. So this way you can completely prevent DNS leaks and so on that are commonly problematic in Tor usage and such. And we have memory and PID sandboxing. Again, these are unprivileged. You should and must use control groups when you can, but using control groups typically require an entity to set up the control groups and an unprivileged entity using it. So when you don't have them, you have these. Safe SETUID is for safe user and group switching. So this is typically used in daemons that change user to an unprivileged user. This way you can also make SIT change user with it. So this is the idea. And we have ghost mode. Ghost mode is a bit of a fancy mode. For those who know seccomp level 1 will understand. Ghost mode is where SID actually closes the seccomp notify file descriptor, and as such it detaches it from the sandbox process, and all hooked syscalls from that point on start to return enosys. This means you can open your files, open your connections, enter this mode, and then it's all the resources you have. You cannot open anything new anymore. So you can have a very confined server this way. On top of this, we have namespaces and containerization and SID OCI, which I'm going to give another talk today. Everyone is invited in Containers Dev Room about this. And finally, we have learning mode with Pandora, and that I'm going to display right now. Hopefully it will work. So let's see. Can everyone read what's written here? It's a big fat command line. Yes, I will explain to you. Don't be scared. So Pandora profile is what you do actually. Like you can do Pandora profile ls, and it will give you a file. This is how easy it is. But we will actually, and it will give you a profile, right? I will show you a bit more about this, but let's do Firefox first. However, Pandora cannot figure out everything about the sandbox process, so you have to pass some options to SID. And here we pass 3 options. One of them is allow unsafe memory. This is because SID by default enables VX restrictions, memory deny, write execute. And Firefox won't work with that because of just-in-time compilers and so on. Allow unsafe libc is to prevent setting AT secure auxiliary vector, thereby LD preload is usable inside the sandbox process. And Firefox has a LD preload sandbox. This is how we make them use it. And allow unsafe file name is SID by default prevents shell special characters in your files. However, Mozilla Firefox actually creates profile names with curly braces, so we have to do this as well. And finally, this filter read is, don't worry about it, this is for filtering out process name changes, which we also prevent because this is typically what your malware does as the first step. So I'm going to go as a private window to leeches.org now. Let's see, we have Firefox running here just normally, and let's try to play a game just real quick, just to show you 3D also works. And I'll try to get checkmated really quick. Okay, it won't work. I was hoping E5 and then Queen H4, but whatever. All right, so 3D is working, right? So let's actually shut this down now and come to the fancy part. Pandora will take a bit to generate the profile. It takes a bit because it checksums all the binaries and so on. Anyhow, it's finished. Now let's take a quick look at the profile. So these are the options we have passed manually. This is the profile directory. The pet component limit is by default 3. You can make it longer, then have bigger profiles and so on. That's up to you. The cache directory, devnull, and so on. And here we see x-access, pulse, audio access, and so on. Access to the system bus socket. And then we have Firefox. And then we have the network accesses. And here where it gets a bit fancier, right? And Pandora does the needful to reverse DNS, so you get a command. And here we have all the connections that it did. And even we are in private mode and only going to leeches, somehow it still accesses Google. I don't know why. No. But the more you use it, the more you understand everyone is tracking you, even if they say they don't. Anyhow, I'll scroll a bit down to be fast. These are all the libraries and so on. I should show you the IOCTL. Yeah, here is the IOCTL requests that are actually done by Firefox. These are mostly DRM requests, and these are allowed, so 3D acceleration and so on works. Finally, we have executable verification, where you have the checksums of all the binaries and libraries included that Firefox tried to execute, and these are all listed here. All right, I will not do any changes to this file, and I will just try to execute Firefox with this now. And this is now running in enforced mode, and Sid is using this profile. Now I'll try to go to leeches, and as you can see, it just works. But if I try to go to some other website, it's not gonna work. So you can have a profile that just goes to one site, or you can also do some kind of kid mode or whatever. And yeah, just to make it complete, playing a game still works. Hopefully, yeah. Okay, let's try getting checkmated again. No, but I'm not lucky today. Anyway, this is all I have to show. And yes, thank you everyone for listening. Now I can take questions. Okay. That's a big question. Sidbox 1 was GPL2. I should repeat the question. Why is it GPL3? Because, all right, Sidbox 1 was GPL2. We upgraded it to GPL3. And GPL, as far as I know, is the only license that's tested on court, right? Like real life usage. So that's the only license that I trust. But I'm not too evangelical on licenses, to be honest, but that's the one that's free and that's tested on court. So
we have one question from the metrics channel. What operating system is best to build this on, and what are the requirements?
Okay. Yes. SID only works on Linux because it depends on seccomp. But architecture-wise, you can run it on any architecture. 32-bit, 64-bit is fine. Apart from that, SID by default only needs seccomp, and this is by default enabled in almost every kernel, so you don't need to enable anything. If you need to enable Landlock, then you need to enable config Landlock and add Landlock to config LSM. That's all you need to get it set up. Yeah. Yes, please.
Do you have any docs where I could start reading and start to get interested?
Yes, go to man.exerbolinux.org. You can also get them installed. I should have repeated the question, right? Where can I learn more about SED was the question. I'm sorry, this is my first talk. We have extensive manual pages, and they're also converted to HTML. So just go to man.exerbolinux.org. Start with SED.7 and SED.2 manual pages. You'll learn a lot. And just come over IRC and ask if you want. Yes, please. Do I have performance numbers? I do have performance numbers. It's in the Git3 bench log directory. You can check them out. But typically, SID comes with 10 to 15% overhead. Yeah.
Yeah, we have also one follow-up question on the metrics about the requirements that, like,
Yes.
Thomas Moon was trying to run it on Debian and it didn't work for him for some reason. So
okay.
maybe if you can follow up on the metrics.
All right. I'll do that. Sure.
Any other questions in the audience here?
Yes, please.
The profile is text-based.
Yes.
Can you edit it?
Yes, of course.
Remove everything.
Of course.
What to prevent it to access Google Ads services.
Exactly. You can just delete the Google there and just run SID like that, and it will not be able to access Google anymore. It's just something auto-generated. I wanted to show you. Learning mode makes this very easy, but you can do whatever you want with the profile. It's just a text-based profile. Yeah.
No other questions? Yeah, there.
Yes, please.
Does it run in user space or
There is no kernel component. Yes. Does it work completely in user space is the question. Yes, it is just a simple Unix tool. You don't need SETUID, you don't need eBPF, you don't need nothing. And everything works as an unprivileged user, so you don't need anything for this. Yeah. Yes. Any other questions? Yes, please.
At some point, I think you mentioned dynamically changing the configuration from inside.
Yes.
Can you tell us more about that?
Yes, of course. Let me repeat the question. I'm learning. About the dynamic configuration, the question is how to do that actually. It's really easy and you can do it with shell tools. The idea is to make stat requests under the virtual path dev sit. So you do dev sit allow read etc shadow, for example, and you stat this path. And statting means test -c, for example, in your shell, or anything you can use. You can use shell scripts. We also have libsit you can use for this. For the API, but it's pretty easy, and this is what we use in Exerbo. We use complete shell utilities for this. Yeah. Yes.
Would you see any advantage in running SID in a containerized environment for software that is running in the cloud?
Okay. Yes, I'm repeating the question. If SID is a good idea to run in containerized environments. This is more of a question for the next talk where I'm going to display that. And the answer is yes, you can just use SID. SID is just a general purpose sandbox. You can use it with containers or not. So yeah, the short answer is yes. The long answer is you're welcome to the next talk. Thank you. Thank you.